Great having you here, Roland. Great. Johnny. Wonderful. Gentlemen, I'm not sure if I have to introduce you, just in case we got newbies in the tech industry here. I'm going to introduce quickly. Ref, you are the Vice President, Omniverse and Simulation Technology at Nvidia.
Yes, I am.
And Roland, you are the CEO and President of Siemens. So thank you for joining us here at the Sofa of Wisdom, as we call it. And I mean, it's day one at the fair. What's the feeling so far for you? What have you seen a lot already at the fairground where you say, wow, this is amazing?
Yeah, I mean, I had a chance yesterday to walk the booth. Just not every exhibition here, but many of them. You see the vibe, you see the next level of technology which we're bringing to our customers. It's getting more and more digital, and yet for our people at all the exhibitions, a little bit more complicated to explain what's in there in terms of digitalization, value for customers. So, but they do a great job in showcasing what technology can do.
And Ref, when we say it's getting more digital and more complicated, I think this is where you definitely step in regards of making it visible.
So, absolutely. I think this is the second year I'm coming to this show. I think because it's becoming more digital, people like me have a more natural place to participate here. It's really amazing to see what all the energy here, especially in the Siemens booth.
Wonderful. So Siemens booth, AI, Nvidia, great partnership. Jumping in right here, I mentioned in the beginning, AI is transforming the industries. How exactly is that going to happen?
Well, I mean, the basic idea is, and this is our strategy in one sentence, we are combining the real and the digital world. And in doing that, we can leverage the power and the speed of software in making our hardware better, in reducing the energy consumption or the way how we consume resources at all. Because it's all in the design phase, in the manufacturing phase, in the operation phase. And we can create a digital thread in all these phases. You can have a better leverage of your hardware and make it even better. So that's a basic idea. You need a lot of technology to do that. You obviously need a lot of data. But you need also processing power. You need the intelligence behind it. AI and the large language models, they are a booster. The booster is basically the enablement to really interact with technology in natural language. This was the big bang which happened when ChatGPT came to the market. But at the same time, I mean, if you go digital, obviously you want to see what you're working on. So this visualization, rendering, how you call it, is getting more and more important. And I mean, everybody knows Nvidia from the great silicon, but maybe the magic is the combination of the great silicon and the software stack on top, which we are integrating into ours in order to make really this immersive photorealistic representation, including the AI capabilities which you have got and we have got available to our customers. That's the magic.
And the magic happens when Nvidia comes into play and contributes.
Yes, our special place in the ecosystem has been to build the lower levels of the computing stack. We build chips, systems, data centers, networking, all of the software, all the way up to stopping at where the applications and solutions come from. And that's what Siemens and Roland and the team create here. About a little over 10 years ago, the big bang of AI started on our platform. We build these special computers that made it possible for us to have the amount of compute to process all of this data and turn them into AIs. What we're talking about here with the Industrial Metaverse and the collaboration we have with Siemens is how we're going to bridge the real world, the world of atoms, into the worlds of ones and zeros, into the IT world, so that we can apply these superpowers we're getting from AI to all the things we want to do in the real world, all the things we want to design and build and operate. And so this is a very special partnership for us because Siemens is the perfect company with the all of the technologies and all the spaces Siemens participates in. They naturally Siemens is a natural bridge from the real world into the digital. And then when you combine that with NVIDIA's technologies and what we're doing with AI and moving the frontier there, I think it's unique and special.
Very special. But what my question is, why do we need the industrial metaverse? Because we are quite far with technology. We have all these tools here. What's the industrial metaverse necessity?
That's a really good question. You know, the term metaverse has a lot of connotations that are maybe different than what we're talking about here with industrial metaverse. Largely, when people think the term metaverse, they're thinking about virtual experiences of worlds that don't exist. They're fantasy worlds. They're video games. They're social experiences. Here, we're grounded in the real world. And what we're doing is taking the real world and trying to represent it in software, along with all of the rules of the real world, which is physics. Take the actual physics of the real world and represent it in the digital world. Once you have that, everything that we do out here in the real world, all of the things that take time and a lot of materials and energy and money, we can do inside the digital world. So we can design these things at a speed that would be impossible to do in the real world and do it much more efficiently.
Which is great.
And let me add on that. And the connotation is really the industrial metaverse. I don't believe in the metaverse, which is more meant for gaming and the like. I don't buy too much into that, even though I know that you made a lot of your way with games. But the industrial metaverse really has an impact on the real world, and this is the big difference. And why that? I mean, obviously, we are already designing our products using CAD tools, and we do a visual representation. Call it a digital twin. But if you really want to go for the next level, what you want to have is, number one, obviously we want to have a digital twin, a comprehensive one, and a physics-based. So it doesn't only look like the real object, it behaves like the real object. When you shake it, when you heat it, or when you load software on it, is the first step. But then if you really want to look into your operations, it needs to be comprehensive. So it's not only the product, it's the manufacturing line, it's maybe the whole plant which you have. Next thing is, if you really want to use it in the operational phase, you need to have it real time. So the round trip of data, so data flow from the shop floor, from the cameras, has to go up to the cloud and has to go back at the same time if you download software to make it better. The next point is, if you really want to have this immersiveness, it has to be photorealistic, because it makes a difference whether it's just about what you see, whether it's really the real world. So if these all elements come together, then you can do a lot of magic. Again, you can travel back in time and see what's happened in the past. You can go into the future, but you also can look. You can walk on a deck of a ship and look where everything is really exactly in place you want it. And if not, then you move it and data round trip. The data go back to your model and fix it there. So it's productivity. We are aiming for really driving the productivity of, is it the industrial world, is it the mobility space, public transport, is it healthcare, any kind of area which we're covering in using this technology. It doesn't go in one step. You have to go forward step by step. Technology is there. Some minor details to solve. We talked about synchronizing timestamps, minor details. But we get there step by step. And with each step, you can see the benefits which happen when you use this technology.
Benefits is my keyword here, because it's not just about saving energy and time. I think it's also for the workforce that there are tremendous benefits for people actually working with robots, having tasks. Who wants to jump in here?
Well, I think first and foremost, you mentioned robots. We've had robots for many years in the industry, but the robots that we have today are largely not very intelligent, and they're largely blind. They don't actually see and react to things based on what they perceive in the world. They're just programmed to do the same thing over and over. In order for us to really unlock the benefit of robotics and automation, we need to have intelligence that can understand the world and operate on that. And to create that intelligence, we finally have a way to do that with all of the modern AI technologies. But the way AI works, you need to feed it data, information, life experience before the AI can be trained to do the right things. And that life experience has to come from somewhere. We're not going to get it from the real world. We're not going to have robots learn how to operate heavy machinery, drive cars, and do all of these things out in the real world first. They'll do it inside a virtual world, inside the Industrial Metaverse first. Once they become smart enough and we can trust them, then we can bring them out into the real world. And so the photorealism that we're talking about is really about simulating the physics of light and matter so that the sensors a robot uses, we can replicate that inside the virtual world. So what they learn there is correct, and then we bring them out here. When we bring them out here, there's not much difference between what they experienced inside the virtual world and what's here.
I mean, which is great. So the testing actually can be done at a time overnight, on the weekend, and we don't have to worry about that people have to do that task over and over again.
That's right.
So
let me share a use case which I found really mind-blowing. It's the grip in the box, which is quite complicated. You have to train a robot on it. Now, what we can do is, even if you don't have a physics part available now of a part which you want to grip, you can throw this digital representation of the part into a box, thousands of things. And then you can train the robot with their cameras and everything to make a right grip in the digital world. Here comes the problem. If it's not photorealistic, if you don't see the reflections, different lights, then the training is not worth anything because you train just artificially. But if you really have this immersive, full photorealistic representation, again, different lights from different areas, the training of this robot is perfect. So what you can do is, even if you don't have a part available yet, you can, over the weekend, train the robot. On Monday morning, the parts are arriving, you put them in a box, and the robot does a perfect work. This is what technology can do. And this is a more intelligent robot. It's not a standard. And maybe the robot can even recognize train it on different parts, recognizes every kind of parts you're throwing in. This drives productivity and makes the availability of robots in different places much, much more realistic or faster.
And that already kind of moves into the next question, talking about the partnership between Siemens and Nvidia and how it can help our customers actually to accelerate their digital transformation. Who wants to start on that?
Let me give you a little anecdote. I think this is the first time when I traveled to the West Coast. I think you have been there in person. Jensen was dialing in. I had a feeling that it's good to talk to Nvidia at that time. This was before you overpassed your $1 trillion evaluation. And we were sitting together, and it took us literally 5 minutes to figure out that something great can happen if we bring these technologies together. And this is where it started, where we said, okay, let's give it a shot. Let's give it a try in order to make this work. And I mean, there are ups and downs. We had some points, the arguments, good ones, because they always brought it a little bit further. So the key is really to get this technology seamlessly integrated. And the latest step was that we say we have our simulation and software suite, which gets where you can really draw your pictures and your drawings, CAD drawings of your parts. And then you have a plug-in where you can boost the whole thing really into the photorealistic world and look at it. So this is the next step which we talked about. So and we're evolving because we need to see how we can bring this technology as seamless as possible to our customers. And sometimes we party together, you know.
Well, he's a great dancer, if you guys don't know.
Well, Hannover Messe definitely...
Surprising, but he is. He's very, very good.
Hannover Messe definitely is a good place for partying too. But I mean, party also at Nvidia, you developed tremendous things. You came from gaming industry, but now you're helping the industries with photorealistic ships, for example. I've seen that example where there were, how many parts have been simulated? And
I believe the ship you're talking about is the HD Hyundai,
yes.
a complete model with all of the parts and everything inside that ship that Roland demonstrated on Jensen's keynote stage at GTC. I think it was last month, although it feels like it's been many years. We have the demo running here in the booth, so I encourage anybody that's here to go take a look at it after the session. That my understanding is that there's millions and millions of parts.
7.5 million.
7.5, and when last I checked, there was something like 15 billion triangles that comprise the whole scene. Something that's been it's been impossible to visualize something of that scale and that much detail in real time in the past. But it was fairly trivial for us to do it by injecting our technologies into your Team Center suite.
This just digested. This we are talking about something like 20, 30, 40, 50 billion triangles.
Yes.
Is there enough computing power? I mean, think of that. And if I may, I'll talk a little bit about computing power. One of the fundamental problems we've had for many years now, where we've been talking about digital twins and the power of simulating things in the virtual world. This idea has been around for decades. I mean, 20 years at least we've been saying the term digital twin. A few years back, we recognized that there were some trends coming that combined together will fundamentally enable realizing the dream that we had set out for a while back. One of the big ones is the availability of compute. So our computers are getting more powerful themselves. We see this super Moore's law scaling in performance. That's been happening, especially when we couple in the AI technologies and AI acceleration. But the other big one is the availability of this compute to everyone. There's been a trend to move our computers into the clouds. And so you can see the NVIDIA computing stack is now in AWS, Azure, every cloud. Can be in your own private data centers, wherever you need it, you can get this computing power. But by it being in the cloud, essentially anyone who needs it, who needs this computing power, can now get access to it. You don't have to have it under your desk, plugged into some box that somehow you procured and managed with your IT folks and whatnot. And so that I think is a fundamental shift that will make it ubiquitous, democratize the access of digital twins.
Still, I do know a couple of people who would love to have this box under their desk.
I still have one, but I mostly use that to play those video games.
We've seen the X at several places here, talking about Siemens Xcelerator, which is our open business platform. I guess this also kind of brings a good perspective to also small companies. It's not just the big game players being active here. Can you elaborate on that a bit?
I mean, Siemens Xcelerator is actually the way how we can realize our strategy. And it has 3 elements in it. Of course, number 1 is it's providing a technology stack. And when I talk about technology stack, it's the sensors, the actuators, the drives, the controllers, the edge devices, up to the cloud, including applications. Because if you walk our booth and if you look at any kind of challenges we see in these industries, it's getting more from selected problems of controlling a line to really optimize the whole flow of a semiconductor production and the like. So therefore, the solutions or the products we're going to sell are getting more and more complex, and this is where we talk about technology stack. So this is the first element. But this is not only our own technology, it's quite a lot in it, but we need others too. This is the second element, it's an ecosystem. The beauty of it is, if we are the company who integrates, and that's what our ambition is, and what I think we do quite well, if we can integrate any kind of technology faster and better than anybody else into our technology stack. So that means If you use our stack, you know it works with Nvidia Omniverse. It's embedded, we have APIs, we get in sync. Then you know that it's kind of a whole ecosystem which works for you. Now comes the third element. Since it's not buying a box where you look at the specification and you click it, you buy it, it's really a little bit more complicated. This is the challenge of our booth people here as well. You need to inform yourself. So it's a marketplace. This is the third element where you can inform yourself, where you can look for good use cases, but you can also transact. Why is it so important? Because, of course, we are sending to our big customers, we're sending key accounts, maybe me, myself, go there to talk about our relationship. There are hundred thousands of small and medium-sized enterprises. They have to make their digital journey as well. And they need to have a very, very easy access to technology. So they can actually look into the marketplace, they can buy, they get a technology stack delivered, which is hardware and software, but they can also benefit from a pre-configured solution which just works. So this is the last element, and we are working on it very hard. The key would be easy to plug and play and easy to use. So make technology accessible as easy as possible so that customers can use it in scale. That's what we're working on, last point on this. In order to help a little bit, amongst the ecosystem, we also have systems integrators over the place in different countries, different regions, the local ones, the global ones, the special ones who are working just for chemicals. They help stitching technology into a legacy kind of environment in order to make this technology accessible. It's all about scaling out faster and help driving the productivity, but also sustainability agenda for our customers. And we need great partners, and this is a great example.
Talking about great questions from the audience, which I will take after this last question to you from my side, and then it's your turn, dear ladies and gentlemen, to raise your most pressing questions to our speakers here. What's next? I mean, now that we have all these solutions and they are just in the baby shoes, I would say, there is so much more potential. What's on the list?
From my perspective, what we're doing right now is as awesome as it is and as powerful as it is, it's just a tiny bit of what's about to come. What's great, though, is just by getting all of this data integrated together, harmonized so that we can visualize it all as a complete thing, like that ship, we've essentially set the foundation for building a holistic digital twin. And once we have those and we start layering on the levels of physics and simulation and emulation of all of the systems within it, software systems, we can start thinking about doing the whole life cycle of the product sort of continuously and together. As you start designing a product, you can start designing the machine that's going to build that product, the factory, and start designing the systems that are going to operate the machine that builds the product. And design decisions you make up front will, you can be informed as you're making those design decisions on the ramifications throughout the process all the way through to the end. And so that's what's exciting to me. I think that's a journey that we're starting right now. It's going to take a little while for us to get there. But with the available computation, with the connection of all of the amazing existing software and tools that we have, and most importantly, with artificial intelligence helping us bridge the domain knowledge that's in humans' heads with the capabilities of these systems so that they can actually use them, I think we're going to get there much quicker than many people probably think.
I mean, it's just about whatever we said today is accelerate in using more AI, large language models in our solutions, using more of the technology which we have, make it easier to use, easier to implement, and really scaling. The building blocks are there already, and to really execute faster and make it, again, as I said, for example, from a digital twin of a product, make it more comprehensive, and using much more the power of the data and the technology which we have. So it's let's put it in short, just accelerating execution.
and it's mind-blowing what we get as results. Thank you so much. That was it from my side with the questions now, ladies and gentlemen. Now I'm handing it over to you. Who wants to raise questions first? We got a gentleman here with the red backpack. Right in the center.
Right in? Oh.
Mike is coming.
Hello, gentlemen. We get to see some amazing innovations round the corner here. I have two questions, and any one of you can take it. My first question is, with all the integration that we see when it comes to manufacturing and technology coming together, accelerating the pace of manufacturing, how do you plan to make it more inclusive? Because, of course, there are large organizations which can afford the technology to sort of grow faster, but what about the smaller or the mid-sized organization? Because that will originally, on a accumulative basis, drive growth for any large economy when it comes on the manufacturing side. My second question is, I belong to this news organization, CNBC, in India. I want to understand your plans for India. It's the fastest growing large economy today. A lot of scope in various sectors which are being displayed here, automotive to semiconductor to shipbuilding. What are the attractive areas, and how do you see India when it comes to integrating your technology in one of the fastest growing large economies in the world today? Thank you.
So actually, eventually question number 1 and 2 goes hand in hand. Let me start with the second one. We strongly believe that India is really taking off. The last years have shown that your growth rates are amazing. You're attracting more and more high quality products or complex products manufactured in India. You have a government which is doing the right things, improving the infrastructure, logistics infrastructure, communication and the like. Actually, your government digitalization is extremely fast. So therefore, and the potential is huge, because in times where people talk about resilience, there's a certain element of local content which moves to India. So therefore, very bullish. Yet, this is exactly what I said before. You have the big companies. I mean, Tata and the like. I mean, they know how to use technology. But you have hundreds of thousands of small and medium-sized enterprises. They need to get access to this technology as well. And here comes your first question. And the short answer is, again, Siemens Xcelerator. We need to go digital. I cannot send my sales guys to 100,000 small and medium-sized guys Indian. This is impossible. And the second element would be, you will definitely not find a small Indian company which goes for the full-blown industrial metaverse. That is completely killing. But little steps, increase your level of automation, increase your design capabilities, make it digital. So in each step provides you, number one, productivity, so it pays off. And each step brings you closer also with the capabilities, which brings to the last element. We're spending a massive amount of money in training and educating our own people on new technology. And we are also opening our platform with learning, as a learning platform, how we can educate people who are using our software, our technology stack to make it work. So therefore, this is a combination, and it's definitely targeting for small and medium-sized enterprises.
Any more questions? Hands up. There is one. Sina, towards the light pillar.
Hi. Any one of you can take this. AGI, is it coming? Should we be excited? I'm talking about artificial general intelligence. And what will that do to companies like Siemens, to manufacturing?
AGI.
Do you want me to take it?
You take it.
Okay.
You take it.
AGI is one of those terms that's kind of ambiguous. I think it's very hard to define what AGI is. If you go back 10 years, when people were using the term AGI, they would describe tasks, certain things that would require AGI, just general intelligence, to do, that we are actually doing right now. Some of the things that LLMs and these modern transformers and AI techniques are doing actually qualify for that. I actually don't think that's the right question. I think the question is, given what we see with the technology, what the potential of the technology we have today is, how can we apply that to our existing systems, our tools to assist humans to do much more? Everything the people in this conference are doing is really hard. That's why everybody is gathered over here. We want to learn how to do it better, to do it more efficiently, to do it sustainably, to design better things that are safer and better for society. And so we should just be looking at, with these superpowers that we've just gained from the existing systems, how do we turn them into something useful? And I think this is where Siemens really does come in. Siemens builds all of the tools and systems that you interact with to build factories, to do the manufacturing, to design. And with our current AI technologies, we're going to have to figure out how to integrate these best to make them usable for you.
Perfect. Due to time, we gotta close this session now. Thank you so much. We got the superpower, we got the Superman here to maneuver through the industrial metaverse, that's for sure.
Thanks,
A big
Christine.
round of applause to you.
Thank you.
Thank you.
Thank you so much.